So in this section, we will find derivative of trigonometric functions, okay? We begin with the derivative of sine and cosine first, sine and cosine, and then use them to obtain formulas for the derivative of remaining 4 trigonometric functions, which I think you know, tan, cotangent, secant, and cosecant. So here is the learning objective. By the end of this unit, you will be able to use and apply the formula for derivative of the trigonometric functions and solve application problems. I want you to recall this from your high school, this elementary trigonometric identities from your high school math. And maybe let us quickly review what these trigonometric functions are, okay? I want to take you to high school just for a few minutes if you don't mind. Suppose you are given a right triangle. Let's say this is your right triangle. All right. And this is your angle theta. Let's say this is A, B, C. Now, when I say sine theta, what does that mean? It means actually opposite over hypotenuse. So that means AB over AC. Okay, so some people call it perpendicular, and some people call it opposite side to that angle, opposite side. And for this one, some people call it hypotenuse, and everyone call it hypotenuse, by the way. And we represent that by H. And this one, some people call it base, and some people call it adjacent side, adjacent, because this side is just together with the angle theta, okay? So in that case, now sine theta is AB over AC. Cos theta is BC over AC, thank you. Tan theta is AB over BC, right? So some people consider this as P over H, and this one as B over H, and this one as P over B. All right, now the reciprocal relation with sine theta is, the reciprocal of sine theta is cosec theta. And that will be just the opposite reciprocal, AC divided by AB. You can write H over P if you like. And this one is, reciprocal of cos theta is secant theta, which is AC over BC, or you can write H over B if you like. And then the reciprocal of tan theta is cotangent theta, and that will be BC over AB, which is B over P. Now, I think some of you remember this in a different way. Some people remember this as sine is P over H, cosine is B over H, and tangent is P over B. Okay, so this is how they remember. And I think in some part of India, how they remember is, PH, BH, PB. So sine, cos, tan, and this is, can somebody tell me? How do you remember that, Pandit?
Pandit, like something. Pandit,
Prasad Hari Hari Bol Sona Chandi to. That was our teacher taught us.
Yeah, okay. So Pandit, can you tell me again?
Pandit Badri Prasad bole har har. And
Oh,
the opposite starts with B from
P, B, and P. Okay. Pandit Badri Prasad,
Bole Har Har.
Ole Har Har.
And now for the denominator, it's a reciprocal.
It's her bully, I think.
Har Har Bole, yes. Har
Yeah.
Har Bole. Okay, yeah. So that is sine, cosine, and tangent. All right, yeah. So Pandit Badri Prasad, PBP, and Har Har Bole. Yes, that's good. That's fantastic. Anybody has any idea how you remember this? Yes, Nabya, thank you so much. Yeah, some people have curly brown hair to produce beauty. Yeah, okay. Some people, some people remember this in another funny way. So this is some people have, okay, let's say curly brown, B represent brown hair, and they put some color. These days people use so much color, right? And they, brown hair turn permanently black. Permanently black. Okay. I don't know how they turn it permanently black. I'm looking that kind of color. If anybody knows that, let me know. I want to change my color to black permanently. Every time I use it, it's just a couple of weeks, it's gone. Anyway, so, this is a funny sentence and you can memorize this easily. Some people have curly brown hair. Some S represent sign, P represent people, H represent have, C represent curly. Okay, some people have curly brown hair turned permanently black. Yes, people remember that way. So these are the six basic, these are the six trigonometric functions that you already know from your high school, from your trigonometry. Now, in this class, our goal is to find the derivative of those functions, okay? And you also remember from your high school, I believe, cosec theta is sine theta because like I said earlier, they are just the reciprocal of each other. As you can see, sine theta and cosec theta are reciprocal, sec theta and cos theta reciprocal, cot and tan are reciprocal, okay? And also please remember this tan theta equals sine theta over cos theta. You can prove it easily. Cot theta means sine theta, cos theta over sine theta, and sine square theta plus cos square theta equal to 1. So you need to remember these elementary trigonometric identities and that 6 trigonometric functions. And now we are ready to actually, find the derivative of these functions. And okay, so here are the formula. We are not going to prove the formula, okay? If you want to see the proof, it's given in your textbook, and but the proof is not required for exam point of view in this course. We just apply the formula to solve problems, okay? Again, those who are really interested to see the proof, then please check in the textbook. So the derivative of sine x is cosine x. And derivative of sine g of x is, you need to use the chain rule whenever there is this composite function. Remember, composite functions always use the chain rule. So this one is a composite function, so you'll get cos gx, g of x, times g prime of x. Okay, now same thing here. Derivative of cos x is sine x. So derivative of cos z of x is minus, oh, this one is minus sine x. Okay, there is a typo. This one is minus sine x. So derivative of cosine g of x equals minus sine g of x dot z prime of x. In the same way, derivative of 10x, we can write this as sec square g of x dot, times g prime of x. And, but we'll find this derivative of tangent later. And we'll use these formulas as well. Altogether, 6 formula we'll be using. But first, let's work example 1. Find the derivative of y with respect to x for the following function. Okay, now recall formula number 1. Okay, so listen. So we have y equals sine 5x. So your dy over dx is, remember the formula here, the formula is right there. So this is the formula that we'll be using for this. Formula number 1, which tells me that this is now, it's a composite function. So I'm gonna use, the mother function, the main function here, sine will change into cosine and just leave the baby inside and then differentiate the baby now. So which is derivative of 5x. So derivative of 5x, we need to do that. So that means you're gonna get derivative of 5x is 5 cosine 5x. I know some of you have already done that in the chat room. That's excellent. Thank you, Kuldeep. And that's how we do. Now, let's look at part B. Part B is y equals cos 5x. I want you to find it by yourself. So cos 5x using this formula number 2, it's a chain rule again. So cos will change into negative sine 5x and then derivative of 5x. You need to find the derivative of that, which gives me minus 5 sine 5x. All right. And let's look at part C. Y equals sine raised to power 4 3x of 3x. This one is a little tricky, guys. Part C is a little tricky. First of all, you need to rewrite this because this means sine 3x whole power 4. Okay, first of all, you need to know that. Now, we need to use chain rule twice, actually. Okay, so first, the outside, the mother function here, there are 2 babies actually inside, you see. First, work with that. There are twins there. So 4, and then you have sine 3x power 3. Now you need to find the derivative of sine 3x, derivative of that. Okay, so 4 sine, you can write this sine cube if you like, and then derivative of that using the chain rule again chain rule. So you will get sine changes into cosine 3x, and then derivative of 3x is actually 3. I can write that directly now. So your answer is going to be 4 times 3 is 12. Let me write it here. 12 sine cube 3x and cos 3x. Okay, guys, any questions so far? So for part D, we did the same thing as we did in part C. So pretty much we rewrote this and we used the chain rule twice. So our final answer is -6 sine 2x and cos square 2x. Okay, now let's go to example 2. Find the derivative of the function. Okay, these are different functions than sine and cosine. So first, let's look at part A. let us suppose that we don't know the formula yet for 10x. Later on we'll use that as a formula, but right now we'll develop that formula first, okay? And then we substitute the formula there in our formula list. So we know that y equals 10x can be written as sin x over cosine x, right? So we know that formula. Now you can use the cosine rule, so that is u over v. So your derivative is going to be dy over dx is, you know, the the cosine rule, right? So uv minus uv, derivative one at a time, over v square. So using the formula, u prime sine x derivative is, you know, look at the formula, list of formula. So sine x derivative is cosine x. You'll get cosine x and copy v, which is cos x, cosine x, minus copy u, which is sine x, and then derivative of cosine x, the bottom part. So that will be negative sine x. So derivative of cosine is negative sine, over b square means cos x square. That's gonna give me cos x is, you know, times cos x will be cos square x minus my negative negative positive sine square x divided by cos square x. Sine square x plus cos square x, you know the formula, right? That is 1 divided by cos square x. So 1 over cos square x, 1 over cos x is actually secant x. So that means that will be sec square x. Now we got the formula for 10. Okay, from now onwards, you can use this as a formula, and let me list this formula here as formula number 5. Sorry, formula number 3. Okay, this one that we just proved. D over dx, 10x is sec square x. And if we extend that a little bit further, we can write that when we have a, you know, functions, tangent functions as a composite functions here, then same idea, sine square x will be g of x here, and then g prime of x. So now I would like you to try maybe part B, y equals cotangent x, cot x. And remember, cot x can be written as cosine x over sine x. And now using the chain rule, let me know what is the formula, and we'll use that as a formula later, okay? So this one is your u and v, and you know the formula, which is uv using the cosine rule minus uv prime prime over v square. And guys, I leave it to you. I'll wait for you guys, okay? Okay, thank you guys. So you all got, you know, absolutely right answer here. So we just use the cosine rule. Using the cosine rule, u prime means the cos x, derivative of cos x is minus sine x, and then copy v, which is sine x, and then minus copy u, which is cos x, and derivative of b, which is sine x, means it will be cos x again, divided by v square, means sine x square. So I can write this as negative, if I take negative common, so I'm going to get sine square x plus cos square x over sine square x. So that gives me, on the top I got 1, negative 1, and on the bottom sine square x. So we know that 1 over sine x is cosecant x, cosec x. So this will be negative cosec x. Okay, now we can use this as a formula, and let me list that as a formula in formula number Formula number 4. No. Formula number 6. Okay, so this one is the formula we just proved. Cot x is negative cosec square x. In the same manner, we can prove this cosec x and sec x. I want you to try these two just for fun, okay? Part C and part D. You may want to try those two just for fun. Let's go this side. So part C is y equal to secant x, and part D, y equals cosecant x. Again, this one is very similar to part A and part B. What we do is, we change this secant x into 1 over cos x, okay, cosine x. So, and we can use the quotient rule, u over b. So we know the formula, ub minus ub prime prime b square, and using that formula, u prime, that will be 0 times cosine x minus 1 times, derivative of the cosine is minus sine x, over b square means cos square x. So the first part is 0 minus negative negative positive. So you'll get 0 and then sine x over cos square x. You can write cos x times cos x. Okay, so that means you can write down sine x. You can split it in this way. So you can split sine x over cos x times 1 over cos x. So sine x over cos x is actually tan x, and then 1 over cos x is sec x, okay, secant x. So that is the formula for sec x. So derivative of sec x will be sec x times tan x, or tan x times sec x. So we can use that as a formula, and we have already written that formula here. So derivative of secant is, you see the formula number 5, we just proved that formula, right? Formula number 5 here. Okay, in the same manner, you can prove this formula from part D there, but I leave it to you guys. And let's move forward. So let's move to example 3. Now you have all the formula. Okay, you have all the formula, and you can solve this by yourself. I believe what I'm going to do is we'll do one question, let's say part A together, and then you will do the remaining by yourself in the breakout room. Maybe this will do one questions from example 3. Which question do you want me to do? Let me know, and then remaining you will do in the breakout room together with your friend. I'll do one questions from example 3, one question from example 4, and the remaining you will do by yourself. C, okay, good. All right, guys, let's try part C. So in part C, y equals cotangent or cot 3x power 4. Again, using the chain rule twice, very similar to what we did in example 1. So your derivative y prime will be, use the chain rule. So first differentiate the mother function, leave the baby inside. So leave the baby as it is, which means 4 cot 3x raised to power 3. And then you need to find the derivative of cot 3x. You need to find the derivative of that. Now, this can be written as 4. This is cot cube 3x, and derivative of cot is, you already know. What is the derivative of cot, by the way? We have already proved that here somewhere, which is minus cosec square 3x. Okay, leave the baby inside, and then you need to find the derivative of this one. So we need to use the chain rule twice. So use chain rule twice. So your final answer is going to be 4 cot cube 3x, and this will be negative. I just want to write that negative, and this will be cosec square 3x, and then the derivative of 3x is simply 3. So that's gonna be negative 12 cot cube 3x and cosec square 3x. You can simplify, further if you want, but you don't have to. All right, and let me do one problem from example 4. Is there any?
1/2.
Okay, yes, excellent answer. So when I give these questions, like these kind of questions, I see some people, what they do is they do the first part correctly. Okay, so this y prime will be negative, the cosine will change into negative sine 2x, and then they use the chain rule. Great. And then I see that what they do here is they do this, they write this sine pi over 6, and then the derivative of that, something like, they will write 1 over 6 or something. But that is wrong, because this one is a constant. There is no x. Remember, there is no x. So therefore this part is 0. Derivative of that part is 0. So your answer is 2 sine 2x. That's it. Now part B. So the part B will be, again, using this y, using the chain rule. We have y, let me just copy the question first. Y is negative cosine 7x squared minus 4. And so your derivative y prime will be negative. The cosine will be negative sine, and 7x squared minus 4. You see that using the chain rule. And then when you do this, it's a composite function, and when you find the derivative, you need to use the chain rule, and then you need to find the derivative inside. So 7x squared minus 4 derivative, which gives me negative, and negative will be positive sine 7x squared minus 4, and then this is going to be 14x. That's it. So you will get 14x sine 7x squared minus 4. Okay, that will be your final answer. And let's do one more, part E or F. I'm not sure which one you want to try. Maybe part E or maybe F. Maybe E would be interesting, I think. Let's try part E. Y equals, let me just copy the question, 2 sine x over 3 2 sine x over 3 minus 2 sine x. So we need to use the chain rule, that cosine rule. That is clear to everyone, right? So u over v. So what is the derivative? That is going to be, now just copy the formula, write down the formula, uv minus uv prime prime over v squared. So that's going to give me u prime is 2, and sine x, the derivative of sine x is cos x. Copy b, which is 3 minus 2 sine x, minus copy u, which is 2 sine x, and derivative of v. So what is the derivative of b, by the way? It will be Derivative of 3 is 0 minus derivative of sine will be cosine. So 2 cosine x over 3 minus 2 sine x squared. Okay, so that's gonna give me, now we are done with the calculus part. Okay, we are done. So we just found the derivative. Now high school part, because it looks really ugly, so you may want to simplify it a little bit further to beautify it. Okay, let's try. So when you multiply that, you're going to get 6 cosine x minus 4 sine x times cos x, negative negative positive 4 sine x times cos x over 3 minus 2 sine x squared. If we can cancel anything, you can cancel that out. I see that we can cancel this too. So our final answer is going to be 6 cos x over 3 minus 2 sine x squared. That should be our answer. Any question, guys, so far? Okay. If you have any question, let me know. Otherwise, what you're gonna do is I'm gonna split you into, okay, let's do one thing. Let's take a break, and then after the break, I'll send you to breakout room. Okay, I'll split this class into breakout room so that you can work together with your friends.